Well, hi. Hello, everyone. Well, thanks for joining us today. We will be focusing on build your first blended app on Fluent. Well, so let's talk a little about me. Protocol Whisper.it. I'm doing DevRel on Fluent. What we're going to do right now is just start talking a little about what Fluent is, but not that much, and then we'll just jump straight to what we care about, that is the live coding session, on how we can build our first blended app. So what's Fluent? Fluent is the first blended execution layer. Fluent is an L2 scaling solution designed to execute Watson-based applications. And how it works, what's different about it, what's the new thing around Fluent? Well, we all the state changes that we do in our VM are compressed using CK-proof, in particular snarks, and we only have one VM. It's not like we have different VMs and they like intercommunicate with each other. We only have one VM, and how we enable support to other languages that are not like the one that our VM is built. Well, these are achieved through special system contracts known as compatibility contracts. This means like the Fluent team can easily spin up any other VM in our VM, since we have like this base that is wasn't, and this led to have like community VMs in our single VM. This means like developers, if you have any idea to say, hey, I want to implement, I don't know, TypeScript in Fluent, yeah, you can do it using the compatibility contracts. You will need to do the transpiler thing and all of that, but you can do it. And that's the good thing, because this opens up a new room to, okay, I have this app, I have my Solidity app, and there's some things that I cannot do in Solidity at the moment, but there are some things that I can do in Rust or in any other languages. So you can like blend those ecosystems and then build your app for your needs. So what's there for devs on Fluent? We have similar developer experience building EVM apps. Let's say you come from an EVM background and you want to deploy an app on Fluent. The only difference that you will see if your application is only EVM, you will only need to change your RPC, and that's it. You can deploy it. You can build apps that were impossible to build on EVM support languages using Flint-based Rust SDK, computation-heavy apps. This makes more sense if you, let's say you are designing a game and then the game has a lot of heavy computations in the backend. Let's say, I don't know, you are designing a chess game. So now you need to say, hey, I want each in my table, like each of the pieces that I have from my chess, where they need to go. You will need to do that calculation, right? So doing that in EVM can get a little bit tricky, but then you can use like Rust crates that are audited, that are widely used in the ecosystem. So you can like just import that crate. Crate is just is the same as packages in npm. So you import that crate into your smart contract that is in Rust, and then you can call that part from your Solidity smart contract. That's the cool part. And of course, three is blended apps. So yeah, I think that was all for just giving a little intro on what Fluent is. Let's just jump into the live coding session. So what are we going to build today? We are building a blended app, Rust and Solidity. We will generate a random number using the rand crate seeded with data from our VM. So what crate are we going to use? Let's just fit here and let's put rand crate. So as you can see, this is a well-known crate in Rust, has a lot of support. You can see how many downloads it has. So here we're going to explain how we can use this type of crates. It's not only I cannot only use this crate. You can use any crate that has the no standard support. In this case, this crate has no STD support, so we're going to use it. And what are we going to do? So we have Alice, and Alice will execute get random to our randomgen.sol contract, because we're going to have two smart contracts, one that is in Solidity and the other one that is in Rust. And so Alice will get random to the Solidity contract, and our Solidity contract will call the get random from our Rust contract. Our Rust smart contract will return a U256, and the Solidity contract will pass the U256 to our user that is Alice. The requirements for doing this, only need to have our Rust compiler set up to the target wasm, Fluent Base SDK. So we'll need to put that in our cargo.tom, and Hardhat just for deploying, and the gblend tool. This is our new tool that we are providing to developers, so you can run commands in the terminal and you have this template of how you can use our stack. Okay, so let's jump into this. Give me a second. This is a little tricky. Okay, cool. So I don't know if you guys can see this, so I'm gonna just zoom a little bit. I think that's okay. Okay. So here, if you install our gblend tool, what you need to do is cargo install gblend. I already did this. I'm not gonna do it again, right? And then you can execute in any path in your terminal that you are, just the gblend command, and you will get something like this. You will say, hey, welcome to the gblend dev tool, choose your setup. And this is our basic examples for you to try to play. So we have like Hardhat JavaScript, Hardhat TypeScript, or a Rust application. In this case, we are doing the blended app. So we will do this custom flag. It's called blended app. So as you can see, now we have our template here. It's not that it's something that strange. It's just a Hardhat project that have this folder with this Rust app when we have already these the packages that we need for executing our application. And we did this because for this workshop, the scope is to demonstrate how you can build your blended app, but just by doing our smart contracts. So we will do the Solidity smart contract and the Rust smart contract. That's not part of the template. You will only get an easy way for you to deploy this. Okay, so what we have here is just a deployment script, the Rust app. This is just for calling the random, and of course the normal Hardhat configuration, Hardhat config, packet JSON, blah blah blah. So what we need to do here is npm install. So we're just going to wait for this to get installed. Okay, cool. So now we have this. So what we're going to do, if you have a kinky eye, you already asked like, hey, how we can how my Rust smart contract will interact with my Solidity smart contract. Like, how's that happen? That happens in an interface. So let's say you have your Rust smart contract, and in order to communicate to your Solidity smart contract, your Solidity will only hit an interface, a Solidity interface, and that interface we have in the constructor the address of the Rust smart contract. So we will need to define an interface first, and then we will need to define our Rust smart contract, and then our Solidity smart contract. So let's do this. So I don't know. I'll hold this iRust random. That's all. Okay, so we need to put the old stuff RSP, DX, license, identifier, MIT. Cool. And our well-known pragma Solidity. Okay, cool. And why doesn't like? Okay, just let me change my workspace to the version that he wants. This. Okay, cool. And let's fill interface, iRust random, rows random. So okay, what we're gonna define here, we will say our row smart contract will have this function So we'll need to craft the signature of the function that we expect our Solidity smart contract to call from our Rust smart contract. So this will be a function random. This with no parents, and will be external returns. Oh, no, sorry, external view returns. And as we said, this will be uint 256. Cool. Okay, so we're done with the interface, and I think we can just jump into our smart contract. So here we will need to import our run crate, and we will need to import our Fluent base SDK. So and then we can like craft our smart contract in Rust. So first we will need to set up target to WASM. So we'll say okay, CFG, if I'm not wrong, on target arc, and this will be WASM 32. And as we said, we need to craft this with no standard environment. So we are not going to use the normal standard library from Rust. We're going to use the Fluent base one. And no std. Okay, we're done with that. And now let's import the things that we want. So we will use star alloc. This is because since you're not using std, we'll need to allocate and deallocate variables on memory manually. So let me just put here, and we need to do this Fluent base SDK. Cool. Okay, so now we'll need to craft our smart contract. So how is that done? So first we will need to have like a struct. So let's just call struct I don't know, Rust contract. And this Rust smart contract, we have some reference. This reference is because we will interact with our VM and we will expect outputs for it. So we will need to have a context reader and account manager for our smart contract. So we will need to define that. Since we will need to define that, we will say we're going to apply a lifetime. So that's this lifetimes will be context reader. And account manager, that will be account manager. Why we'll need to put a lifetime here is because we are going to reference from in fields that are inside the struct. So we will say, hey, I want this reference to outlive my struct. So we don't want to have a struct that have a reference that it doesn't exist, right? So let's just say here, I have this student, and this will be AM lifetime AM. Cool. So that will be our initialization of our smart contract. Of course, we'll need to define like, hey, this is a contract, so we will implement the derive function. I mean the derive decorator here. We'll say derive, and this is contract. Yeah, it didn't export it how we want it, so we will need to here use Fluent base SDK derive. No, we'll need contract here. Okay, cool. So now what we're going to do is in Rust we'll need to implement some traits to our struct. So what we'll need to implement is our random trait. That random trait means that it will have the same signature as we define in our interface, but we will see that in the correct implementation where we'll literally pass the entirely signature of it. So then our compiler can know what we're trying to do. So yeah, for this, let's just create a trait, random. We'll put here our random function. No, lowercase. We'll need to put this generic saying like, hey, we are using the SDK Share App API. This will call self. And this will return use64. Okay, cool. So now we have our trade. So let's implement our trade to our Rust struct, a Rust contract struct. And here we'll need to put this decorator saying, hey, this implementation will be compatible with Solidity. So we'll put router, and we'll put here mode, and we'll put here Solidity. So as you can see, we define the compatibility that we want. And yes, of course, you can later we will can change Solidity to SVM or whatever tech you want to use. But for now, it's just Solidity. So okay, it already imports it automatically, so that's cool. Yeah, let's do the implementation. So we'll say implementation of these. This is generic. The random trade for our Rust contract, that will be Rust contract with the same give me a second, I think I'm missing something, with the CR, that is our context reader, and our AM, that is our account manager. Cool. So you like it? Yeah, since like we're doing it. CRAM. Cool. Okay, so now this is the cool part. This is how we say that to the compiler, hey, my Rust smart contract will be communicating with our Solidity smart contract, so we'll need to define a signature. So, and the signature will be the same as the one that we put in our interface. So we'll say here signature. Well, sorry, I forgot this. Okay, cool. So we'll go here. Yep, we are expecting the same. So we are putting here this. Just let me erase the semicolon here. Okay, awesome. And now let's implement the function that we want, and let's use our random crate, right? So this will be here, and this will be a self, and this will return use64. Cool. And now let's, okay, so this is the thing. We're going to produce random numbers, but as we know, providing random numbers in blockchains is like a research topic nowadays too. So what we're going to do is mock it. So we're going to generate random numbers with preceded data. Of course, I know this is not like a good practice to do, but for the scope of this workshop is to demonstrate how we can use a well-known crate, is brand crate from Rust, into our app. So let's create a set here, use 64, and that seed will be self, will be CR, because we are accessing data from the VM. So we're saying, hey, I want to read the context of our VM, and we will get here block timestamp. Okay, this is not completing automatically, I think, because I'm missing some imports. Let me see. Contributed Shari API, signature. Okay, maybe I'm missing here. Router. Okay, yeah, I'm missing signature here. And here, this is for the last part, but just give me a guest account manager and guest context here. Okay, I think. Okay, let's see. If we give it an error, then we will debug it. That's it. It happens in live coding sessions. So okay, let's say, hey, I want my random number to be the type of small RNG, just because for this little workshop. We'll say seed will be from U64, I think it is. Yeah, we are getting U64. Okay, we'll pass the seed. And just put random next U64. Okay, I'm missing here. Okay, yeah, it's not it's not auto completing. Okay, cool. So yeah, this is where we almost finished with this Rust smart contract. So let's now tell to our compiler or to VM, hey, I want to deploy this smart contract. Since we are not going to use any custom deployment, we'll only need to implement the deployment function, and then the compiler will know what to do. So yeah, it will be pretty much the same. So let me just do this. I need to delete this. Um, okay, like this. And let's just erase all of these. Let's say here deploy. Um, SDK shaded API. Yeah, I'm just looking at it because maybe you're asking questions, so I need to like, okay, self. Okay, this is awesome. And I think we'll need to define a basic entry point. Since this is just a normal smart contract, we don't have any customs. We'll then pass, okay, my entry point will be my Rosa smart contract. Then we will need to pass the lifetime that we put here. This is a generic lifetime. So here we will say, hey, I want this lifetime to be static. This meaning that it will last till the memory of the memory. This will last until the memory is out. This meaning when the program is it's done. So see, we will ensure that our reference will outlive our struct till the end of the program. And guest account manager, because we are saying, hey, we're getting this from external. So I think is first context reader. Yeah, context reader and guest account manager. So yep, I think this is that's it. This is our Rust smart contract. I don't think I'm missing something. Yeah, I'm getting this. I don't know, maybe this. Oh, we'll see. We'll see. So how we compile this in our template that we did with our GBLAN tool, we have this make file, and this make file will do all the things that for us. We will need only to execute the make command, and it will compile, will declare it target, and it will create the wasm file that we rename it and just clean the stuff for us. So let's see. I don't think this will run the first because I think I'm missing some imports, but okay, let's see. Um, let's go to Rust app, and here let's execute make. Yeah, let's give it a minute. It's compiling. Okay, yeah, we got an error. So let's see what that error is. Oh, okay. I think I'm missing some random from small set. So I have the random here. Yeah, I have random here. And then we need random string core and suitable RNG. Suitable RNG. Okay. The rep contract. Yeah, just give me a second trying to see what I'm missing. Trade. Okay, this should be here. I don't think that's a concern. Random unit 256. And the RAM Context reader, account manager. Okay. Yeah, let's try it again. No, doesn't want to compile. Okay, maybe I'm missing something. Dun, dun. Okay, just let me maybe have a typo. So, but for the sake of the time, I will just do this and to make. Okay, build finish. But yeah, so let's recap this. What we do was creating our smart contract with the correct references. We'll we have the random trait that we say, hey, I want to execute the random function. I want to return IU64. Then we say, hey, using my ROS contract will be called by a Solidity smart contract. So I set up my router mode to Solidity. And then this is the funny part. When we put the signature of it, we say function random string view returns 256. And if you remember, it's the same signature as we use in our interface. And then here we define how we're going to use the random crate. We take a seed from a blog's timestamp. This is not a good practice if we are planning to do production apps. And then we say, hey, our random will be a small random number with a seed from a U64 number. And then we say, okay, give me back my random number. This is a normal implement deploy function that we need to tell our compiler to do it, and this is the basic entry point. Say, hey, you're accessing this smart contract. My entry point will be my ROS contract with all the reference being static. So meaning this will live till the program dies. And yeah, we are done with it. We'll just execute make, and as we can see here, our build is finished. So what we need to do next is to do our random. That's all. So what we're going to do here, we'll need to import our interface. We will define how we can call our smart contract and where you can, what we can do with it. Okay, so I'm just going to copy this because it's faster, right? Cool. And say, hey, import. I want to import my interface. This will be my iROS random. That's all. And that's all. Okay, and let's say my contract will be random. Yeah, why not? Random. So what we'll need to do here, we will need to say, hey, my interface will be public, so we can access it later. And we'll pull ROS contract, right? So just for make it more clear. And we do this to see the address we are interacting with. Okay, so we'll put here a counter. Why would we need a counter? Since each call that we do with our smart contract, it will access the data that we need from the VM. That makes sense when we import here this our context reader. But when we hit it, the context reader get updated for that specific smart contract. So for this, we'll need to update the counter. So then we will have a different seed, and then we can craft our random number. So let's say this will be public, this will be a counter, right? And now this is the funny part. We need to put a constructor. We say, hey, my constructor will be, the params of my constructor will be an address. This address will be my ROS contract. So I just put this like this. My ROS contract will let's initialize my interface with the correct address. So it will be my interface will be initialized with this, with address we pass to the constructor. Where we're missing is the function to update the counter, as I explain it later, why we need to update the counter. Counter, this will be like this, and just let's do a counter plus plus. Okay, why is not okay? I need to put this is star. My bad. And two are we missing? Of course, the function random. So what it's going to do when I head my random function in this Solidity smart contract? So this will be external view returns, and this will return a uint 256. If you have a Ginkia, you will say, hey, but you were returning a U64 in your raw smart contract. Why are you putting a uint 255? Uint 255. 256. I did this because it's all done at the backend, so I wanted to show you guys how is it handled. So let's say Randy, this will be our ROS contract that we define here. We will access the random function. We will return Randy. And we are done. We are done with the blended app. It's what's left. What's left for us is just execute this, compile this, and then deploy it. So let's go straight to it. So we'll say, hey, hard compile my two Solidity smart contracts that we just did. Okay, so I think I'm missing. Oh, I don't have my private key. So this is a mockup private key. So don't worry about like, hey, I'm going to copy your private key. It doesn't matter. Okay, so we have our two smart contracts that are currently compiled. Let's deploy this. Hard hat deploy. Okay, we have a little error here. What does it say? Okay, this is saying because you have an error between my deployment script. I think I set the gas limit too high. Here, yeah, that's too high. That's a lot. I'm not that rich yet. Okay, cool. And yeah, we have our random contract deploy at this address, and we will need this address to execute our task. So yeah, let's copy this address and hard hat run, and our task is called get random. So we say get random. And okay, I think just give me a second. I think I'm missing something here. Add param. Yeah, I need to modify this. Yeah, random number. Oh, I cannot see my screen. Give me a sec. Let me see if I have this here. Deploy compile keywords. Yeah, you see me a second. This happens. I forgot how I can call the task. Mm. Dun, 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 dun. Mm. Yeah, let's see if I get this here. Yeah, why is giving me this error? Well, this just trips. But well, as we can see, we already deploy our random contract to this address, and this is how we can interact with the two Solidity smart contracts and our Rose smart contract. So yeah, I think this will be it for the workshop. Um, so what's next? We have currently released our new docs. So I invite you to see this. It's our docsfluent.xyz learn and our new CLI tool that it's called Hello Fluent, GBlend, sorry for that. And yeah, reach out to Yangmar. I'm happy if you have any questions around this, or if you want to build any product around Fluent. I'm afraid to chat with you and to brainstorm what can be done and what we can craft together. So yep, that's it, guys.